Good morning. So today we're going to discuss chapter 2 of this book, which is algebraic expressions. Okay, under this topic of algebraic expressions, we have polynomials, rational expressions, radical expressions. So let us start first with polynomials. So let us define what is a polynomial. So a polynomial in the variable x is an expression of the form a sub n of x raised to n plus a sub n minus 1 of x to the power of n minus 1 plus and so on plus a sub 1 of x plus a sub 0, where the numbers a sub 0, a sub 1, until a sub n are called the coefficients of the polynomials. So these are the polynomials a sub n minus 1, until a sub 1. The number a sub 0 is the constant coefficient, or commonly known as constant term. The number a sub n, the coefficient of the highest power, or sometimes we call that one as the leading coefficient. So leading because it's the first coefficient that we can see in the given polynomial. And the term a sub n of x raised to n is the leading term. If a sub n is the leading coefficient, so the entire of this, the first term, is what we call as the leading terms. Note that the degree of a polynomial is the highest power of the variable that appears in the polynomial. So for example here, we have 2x squared minus 3x plus 4. So the type of polynomial is trinomial because there are three terms. The first term is 2x squared, followed by the negative 3x, and the last term is positive 4. Therefore, the type of polynomial is trinomial. So as I've said, those are the terms, the 2x squared, negative 3x, plus 4. And the degree of the polynomial is 2 because the highest power that you can see in the exponent of the polynomials is 2. That's why it is a degree of 2 or second degree. Now, the next one is x to the power of 8 plus 5x. Since there are two terms only in the given, then we call that one as binomial. So the terms are x raised to 8 and 5x. And we could see that the highest power of x is 8. Therefore, it is known as the degree of 8. And the third example, we have 8 minus x plus x squared minus 1 half x squared. So there are 4 terms. So we can just call that one as 4 terms. And the terms here are, if I'm going to rearrange this one from the highest power to the constant, so we have here negative 1 half of x cubed, x squared, negative x, and 8, not 3. Correction. This is not 3, but this is 8. Okay, and then what is the degree of the polynomial? As you can see, in the given polynomial, the highest exponent is 3, therefore the degree is 3 or the third degree. And next example, we have 5x plus 1. Since there are only two terms, we named it one as binomial. And the terms are 5x and 1. And look at the exponent of the two terms. So there's only term that has x here, and that is now invisible 1. Therefore, the degree is 1, or you could say a first degree. So second to the last example is 9x to the fifth power. It is the type of polynomial is what we call as monomial if there is only one term given. Now, it is monomial and the term is 9x to the fifth power, and the highest power there is 5. So therefore, the degree is 5. And the last example is 6, and that is only one term. Therefore, the type of polynomial is what we call as monomial. So the terms here is 6. And since it's only a constant, then the degree of polynomial is what we call as 0 degree. Now, let's proceed to adding and subtracting polynomials. To add and subtract polynomials using the properties of real numbers, so the idea is to combine like terms. That is, terms with the same variables raised to the same powers. And that's what we call as like terms. Again, when we say like terms, it is a term or terms with the same variables raised to the same powers using the distributive property. For instance, we have 5x raised to 7 plus 3x raised to 7. So as you can see, the variables x with an exponent of 7, and the other one also is x raised to 7. Now in that case, we can add their coefficients. So adding the coefficients now, we have 5 plus 3 of x raised to 7 is equal to 8x raised to 7. So to make it short, you can omit this step and you can write the answer right away of 8x raised to 7. By the way, it's not your first time to encounter polynomials. You know well how to add and subtract polynomials. So we know that pre-calculus is a preparation for calculus, and the topics covered in this pre-calculus is somewhat like a review of your high school mathematics. So in subtracting polynomials, we have to remember that if a minus sign precedes an expression in parentheses, then the sign of every term within the parentheses is changed when we remove the parentheses. This is what I'm trying to say. The negative of the quantity of b plus c, it says that we are going to change the sign. All right. So if there's negative outside of this quantity b plus c, then the sign here inside the parentheses will be changed to its opposite sign. Therefore, from positive b, it becomes negative b, and from positive c, it becomes now negative c. Or you're going to use the idea of using distributive property and multiplying sign of like and unlike sign. So in this case, negative times b is negative b, and negative times positive c is negative c. So for example, find the sum of x cubed minus 6x squared plus 2x plus 4, that's one quantity, plus another quantity of x cubed plus 5x squared minus 7x. So in that case, I'm going to regroup this one. So I will write here, I have x cubed plus x cubed. So the coefficients are 1. If you cannot see any number here, it may say the coefficient of x cubed is 1. So we have 1x cubed plus another 1x cubed. So we have now 2x cubed. And next, in terms of x squared. So x squared, so the coefficients of x squared is negative 6 and positive 5. So negative 6 plus 5, it gives us the answer of negative 1. And copy the common base with the same exponent. So therefore, we could write here now negative x squared. And the next term in terms of x. So what are the coefficients of x? So we know that the coefficients of x is 2 and negative 7. So what is 2 minus 7? So the difference is negative 5. So I can write now negative 5 of x. And we have another term of 4, but in the other term, we don't have a constant. Since there's only one constant term, then I will just write now the constant term of 4. So therefore, the sum of that now gives us the answer of 2x cubed minus x squared minus 5x plus 4. Now, on the second example is we are asked to find the difference of this quantity. I guess the given are just the same, but the question is now difference. So in that case, we are going to subtract. I will show another method to solve instead of following the same procedure in number 1. So we can write here x cubed minus 6x squared plus 2x plus 4 minus, I have x cubed plus 5x squared minus 7x. So in that way, I'm solving now in terms of vertical method. So if I'm going to do like this, then I'm going to change the sign of the subtrahend to its opposite sign. Okay, so the new sign now here, we have negative, and this must be negative, and this must be positive. So from there, we are now going to follow the rules of adding integers. It's either adding like sign or adding unlike sign. Let us focus first on the coefficient. So we have 1x cubed or just x cubed minus x cubed. So it gives 0. And this one, negative 6x squared and negative 5x squared. So now they are the same sign. So therefore, we are going to add. So it gives us now the answer of negative 11x squared and positive 2x, and the new sign is positive 7x. We're going to add because they are the same sign. Therefore, it gives us the answer of 9x and positive 4, and we don't have any constant on the second term. Therefore, we just bring down the positive 4. So now, the difference now of the two given is negative 11x squared plus 9x plus 4. Okay, so another method for solving this one is I'm going to use somewhat like a horizontal method. So I will write there x cubed minus x cubed, and then I will write there plus, we have negative 6x squared minus 5x squared, 5x squared plus 2x. We have here negative of negative is becomes now positive 7x and positive 4. So simplifying this one, we have x cubed minus x cubed is 0, and negative 6x squared minus 5x squared. So since they are the same sign, so I will add their coefficients. So therefore becomes negative 6 and negative 5. So we have negative 11x squared. And then we have 2x plus 7x. We have plus 9x. And then the last term is positive 4. So the answer are just the same on the first method. Do not forget, in our previous example, this one, the negative of that quantity. So we change the sign inside the parentheses. That's why it becomes now from negative of x cubed, we have negative x cubed, and positive 5x squared, it becomes negative 5x squared, and the negative 7x becomes now positive 7x. Okay, now let's proceed now to the other operation. We have multiplying algebraic expressions. So to find the product of polynomials or other algebraic expressions, we need to use the distributive property repeatedly. In particular, using it 3 times on the product of two binomials. So for example here, the quantity of A plus B times C plus D. So what we did here is that we are going to distribute A to this binomial of C plus D. As you can see here, A times the quantity of C plus D. Next, we have positive B. So positive B times the quantity of C plus D. Then after that, you distribute this again. A times C is AC. A times D, we have AD. We copy the sign, and then we are done on this term. So we have moved on to the next term. So we have B times C is positive BC because they are the same positive, and positive D times positive D, we have positive BD. This says that we multiply the two factors by multiplying each term in one factor by each term in the other factor and adding these factors. Schematically, we have also another method for that. We use the FOIL method. So FOIL stands for, we have F means first terms of each binomial. So I will say that A and C are the first terms of each binomial. So this one is a first binomial and C plus D is another binomial. So those are the first terms. Next is outer terms. Outer terms with this one, A and D are the outer terms. As you can see, they are the extremes or the outer terms. And I stands for inner term. So we have inner term here, the B and C. All right. And L, there is the last terms. If we have first terms, we also have last terms. So the last terms now are this, B and D. Now using that one, we can have now multiply the first terms. The one that I align red one are the first terms. So A times C is AC. And in outer terms, this one that I connect, A times D is AD. And then I now is inner, we have B times C is BC. And the last terms, the color blue one, that line, is B times D is BD. Usually, the outer term and the inner terms can be added if they are of the same terms. So in general, we can multiply two algebraic expressions by using the distributive property and the laws of exponents. So when we multiply trinomials or other polynomials with more terms, we use the distributive property. It is also helpful to arrange our work in table form. So the next example illustrates both methods. Okay, so let us use now the distributive property. So we multiply here now. We have 2x times the trinomial term is x squared minus 5x plus 4 plus, because of the plus sign, plus 3 times, you copy this again, the trinomial term, we have x squared minus 5x plus 4. And now, you use again the distributive property. So we have 2x times x squared, we have 2x to the power of 3. Take note, when we are multiplying the same base, you just add the exponents. We have now 1 here, exponent here is 1, plus the exponent 2 here, therefore it becomes power of 3. Next, we have 2x times negative 5x is negative 10x squared, and 2x times positive 4 is positive 8x. Now, that's the answer of the first term. Now, let's move on to this. Positive 3 times x squared, we have positive 3x squared. 3 times negative 5x is negative 15x, and 3 times positive 4 is positive 12. Then after that, we multiply using distributive property. We are going to inspect carefully to combine like terms. So we have here a power of x cubed, okay? So power of x cubed, there is no other term with the power of x cubed. So in that case, we are going to write now, we are going to copy that one since that's the only term that has the power of x cubed, the power of 3. So therefore, I will write now 2x cubed. Next, we have to look at now to the power of 2. So we have negative 10x squared, and we also have positive 3x squared. So since they are the same x squared, and we are going to combine their coefficients. So in combining these coefficients, since it is negative 10 and positive 3, we are going to subtract. You subtract if they are of different sign. Okay? You add if they are of the same sign or like terms, or the other one is unlike. Unlike sign and like sign. But in this case, they are unlike signs. So we subtract their coefficients. So therefore, negative 10 and positive 3, it gives us now negative 7, and copy the common base with the exponent of x squared. Next, we have in terms of x. So I have 8x and negative 15x. So 8 minus 15 is negative 7. So we have now negative 7x and The remaining term is a constant term which is now positive 12. So copy only the positive 12. And this will be now our product. Okay, let me check again. So I have 2x times the quantity of x squared minus 5x plus 4. So using distributive property, 2x times x squared is 2x cubed, and 2x minus 5x is negative 10x squared, and 2x times positive 4 is 8x. Now, on the next term, we have 3 times the trinomial term. We have 3 times x squared is 3x squared, 3 times negative 5x, negative 15x, and 3 times 4 is positive 12. So combining now like terms, since x cubed has no other term aside from this, so I bring down the 2x cubed, and then combining the like term, we have x squared, negative 10x squared, and positive 3x squared, negative 7x squared. And then in terms of x, 8 minus 15 is negative 7x. And then the constant term is positive 12. So let's proceed now the special product formulas. Anyway, I'm not going to discuss in detail on the other operations since this is not your first time to encounter this topic. So as I've said, this pre-calculus somewhat like a review of your high school math. Now let's move on now to special product formulas. If A and B are any real numbers or algebraic expressions, then the quantity of A plus B times A minus B, the product is A squared minus B squared. The left-hand side, the A plus B times A minus B is what we call as the product of sum and difference of two terms. And the answer now, or the product of A squared minus B squared, is what we call as the difference of two squares. Okay, because A squared and B squared, they are both perfect square. Okay, that is why we call this one as special product formulas. Now, number 2, we have the square of A plus B. If we're going to expand that one using A plus B times A plus B, the expanded form of the square of A plus B, then we can have the product of A squared plus 2AB plus B squared. So on the left-hand side, we call this one as the square of binomial, or sometimes we call it square of a sum. But it is very common to say the square of binomial. But it is also this term as the square of a sum. And if you're going to expand the square of binomial, so the product now is what we call as the perfect square trinomial, whose characteristic for that is the first and the last term, we have A squared, B squared are both perfect square. And the middle term is twice the product of their square roots. So twice, and then the square root of A squared is A, and the square root of B squared is B. That's why we call that one as twice the product of their roots. Yeah, again, on the right-hand side for this, A squared plus 2AB plus B squared is what we call as perfect square trinomial, or some books, they call that one as perfect trinomial square. So whichever is being said, I'm referring to one thing. Okay? Now, for number 3, they're almost similar with number 2. The only difference between the two is that the sign. This is now the square of a sum, and we call that one as the square of a difference. Still a square binomial, but in particular, we call that one as a square of a difference. Whose product now, if you're going to expand this one, is A squared minus 2AB plus B squared. So we just copy the sign of the middle term, just this one. These are the only thing that are different to this. All right. When this is plus, all the terms are positive. And when this is the square of the difference, only the middle term is minus sign. Okay? Because the square of the first term are both positive. The answer is A squared and B squared. Okay, for number 4, we have the cube of the quantity of A plus B. So sometimes I call that one as a cube of binomial, or we could say the cube of a sum. Whose product for this, if we're going to expand, if in case you forgot this formula, you can expand that one as A plus B times the square of A plus B. And then you're going to use distributive property. That is the reason why we have these special product formulas in order for us to shorten our solution. Now, the product, if we're going to expand the cube of A plus B, or cube of binomial, we have the cube of the first term, which is now A, plus thrice, so constant 3, thrice the square of the first term and the last term, plus thrice the product of the first term and the square of the last term. The third term is thrice the product of the first term and the square of the last term, plus the cube of the last term. So number 5 is almost similar to number 4. Instead of using plus here, now we have minus sign. So the cube of A minus B gives us the product of A cube minus thrice the square of the first term and the last term, plus thrice the product of the first term and the square of the last term, minus the cube of the last term. Now, if you have a cube of difference, only to remember that the sign is alternating. So we have positive, negative, positive, negative. But if you're talking about the cube of a sum, then all terms are positive. So please try to familiarize or memorize the formulas so that we can give the answers easily. Okay, so we have now the example. Use the special product formulas to find each product. Now let's start first with letter A. So I call this one as the square binomial. So we have here for letter A. So we have, I will write first the given. We have 3x plus 5 and then quantity to the power of 2. So the pattern for this, let us recall, we have the square of binomial, this one. We have the square of the first term plus twice the product of the two terms. Comparing to the two terms, we have A and B plus the square of the last term. So try to memorize that. So I can write here now the square of the first term. I have first term is 3x. I will show first the solution. So the square of the first term plus twice the product of the two terms. The first term is 3x and the last term is 5 plus the square of the last term. So this is our formula. Now, let us simplify it further. The square of 3x is 9x squared plus multiply first the two terms and then double it or twice. 3x times 5 is 15x times 2 becomes 30x plus the square of 5 is 25. So that's the answer now of letter A. So for letter B, so this is the cube of binomial. Okay, so I will write it first here. We have x squared minus 2 to the power of 3. So recall the formula for this. We're following formula number 5. So I will write first here the formula for this. So the formula that we're going to use here is A minus B so that you will be properly guided. So the formula is A minus B to the third power, whose product for this becomes the cube of the first term minus, why minus? Because this is minus sign. So it should be alternating sign is our product. So we have 3 times A squared, the square of the first term, times B plus thrice of A, then square of the last term, minus cube of the last term. Let's follow that one. So our first term is x squared. So I will write now x squared and then raised to the power of 3 minus the constant is 3 and then the square of the first term. So the first term is x squared. So I will write x squared and then you square times the last term is 2. No need to copy the sign. Okay? Because this one now is being, this formula that we have here are already in the simplest form. So no need to copy the sign. Instead of negative 2, just write there 2. And then plus 3 times, take note, 3 is a constant term because of cube of binomial. So 3 times the first term. By this time, you square the last term, which is now 2 squared minus the cube of the last term. Okay, so 1, 2, 3, 4. So there are 4 terms. Now, after we use that formula, you follow that formula. So we expanded the formula here, and then that's the time we are going to simplify further. So power to a power rule, we multiply the exponent. So therefore, x to the power of 6 minus, you multiply first this one, 3 times 2, we have 6. And then x squared raised to the power of 2, we have x to the power of 4. Now, this one first is 3 times x squared is 3x squared. So I multiply this one is 3x squared, but this is 2 squared is 4. So I will write first here on top. So the product of this is 3x squared, and then this one is 4. So multiply 3x squared times 4. So the product now is 12x squared. And 2 to the third power is equal to 8. So I will just write here negative 8. All right. So actually, it's not difficult to solve for this. Actually, it's very easy if you can only follow the pattern. That is what we call as the formulas. Okay, so try to familiarize for that. Okay, next we have another example. Find each product. So for letter A, this is similar now to our formula number 1. So the product of sum and difference of two terms, or we call it sum and difference of same terms. So our expected answer now becomes the difference of two squares. Okay, so that you will be properly guided, I'm going to write it again, the formula. Take note, you can only do that if they have all the same terms. We could say 2x, the same first term, and the last term we also have the same term, the square root of y and the square root of y. So the formula for letter A, I will say a plus b times a minus b, whose product for that is the difference of two squares, which is now the square of the first term minus the square of the last term. So in doing that, so my first term is 2x. So I will write first the given. So we have 2x minus the square root of y times 2x plus the square root of y. So our product for that will be in this form, a squared minus b squared, or the square of the first term. So the first term is 2x. Then we are going to square minus the square of the last term. So our last term is the square root of y, and then we are going to square. Okay, then after that, we are going to simplify. So the square of 2x, using distributive property, it would be 2 squared is 4, and then x to the power of 2 is x squared. And then minus the square of the square root of y, we have just y. All right, so that's the answer now, 4x squared minus y. Because square root of y times square root of y is equal to square root of y squared. So we can cancel the n-text and the radicand. That's why we only have y there. Okay, now for next example, we have x plus y minus 1 times x plus y plus 1. There are three terms but we don't have exactly similar to that. But we can do something. I'm going to group this term. So this one is x plus y and x plus y are the same. So the second term now is 1, negative 1, and positive 1. So that is now similar to this. Alright? So this is now the product of sum and difference of two terms. So the first term now is a binomial of x plus y. So I can write now the answer for that here. So we have x plus y as the first term, and then it says that we are going to square. So you square that 1 minus the last terms now here are 1. So we have 1 squared. Now, since this one is square binomial, which is now actually the formula number 2. Okay? So expanding that one, we can write now x squared plus 2xy, which is now twice the product of the two terms, the x and y, plus the square of the last term. Take note that the first term and the last term are just the square of each term. And then the middle is twice the product of the two terms, and copy the sign, whatever the sign there in the middle. That's now x squared plus 2xy plus y squared minus the square of 1 is just 1. So that is now the answer.